Hello everyone. I'm going to do another example of improper integrals as we discussed in the previous videos. But this one I'm going to do one other than P series. I'm going to write an integral of quantity x over x squared minus 1. And in here I go from 1 to 4. Before even I look at the lower limit and upper limit, I have to find out, is that a positive function or no? And also I have to know what is the domain of that function. The most important part is the domain, which is x squared minus 1 cannot be 0. And if I factor x squared minus 1, x cannot be 1 and x cannot be negative 1. Then I'm going to look at this integral and I'm going to see one of my lower limit is exactly the number I cannot assign. Therefore, I cannot assign negative 1. Also, the upper limit is 4, and I don't have any issue with 4 because having 4 inside my function, I'm going to have 4 over 16 minus 1, which is 4 over 15. I'm going to put a bracket. But also there is a number between negative 1 and 4. It causes discontinuity, and that number is 1. That's also going to be another parenthesis, but I need a parenthesis open to the right and open parenthesis to the left and open parenthesis to the right, and that's exactly your 1. Therefore, for these two numbers I cannot assign to my function, which is not part of the domain, and one of them is my lower bound, these have to be reassigned to a real number. Therefore, I can get close to negative 1, as close as possible. And what is that number that I'm approaching negative 1? It is a. And I'm going to say the limit as a approaches negative 1 from the right. Then, instead of a negative 1, I put a. But if I want to use this interval to write a definite integral, a proper one, not improper, I have an issue with that 1 because pretty much this is a barricade between negative 1 and 4. Therefore, I cannot assign 1 to that function either. Therefore, I'm going to call this one a b. And in this interval, I have an issue because I have not included in both lower limit and upper limit. And I have to assign a as a approaches negative 1 from the left. Then I have to assign b here, and I'm approaching it from the left, and I have to take a limit. And have you ever seen we take the limit of a limit of something? We cannot do that. In order to be able to find the value of a definite integral, yes, you can apply one limit. That either could be applied to a lower limit or upper limit. Therefore, since I have no choice to apply limit to this side I cannot apply limit. Therefore, I have no choice to go between a and a b. Pick an easy number which can be assigned to that domain, and I can use a bracket in there. And between negative 1 and 1, the easiest number is 0. Therefore, because I had undefined, both ends, I have to find the defined in the middle and break it to 2 parts here. And say a through z of x over x squared minus 1 dx plus Then I go from 0 to b But what is my b? It cannot be 1, but it can approaches 1, which become 0.99999, and I'm going to say b approaches 1. And this is defined, this is undefined, and use the same thing. You take the integral of that piece. Then I have this part. This part I don't have defined in this end, but I have it defined on that end. Because one end is defined, I only gonna end up with one limit. In here, I would end up with two limits because it was the lower and upper. You have to find something defined in the middle. Therefore, in here, one end is a b. But I'm approaching b. It cannot be 1, but it could be 1.000000001. Therefore, I'm going to take the limit as b approaches 1 from the right. From b to 4, I'm fine with that 4. Therefore, right now, I have 1, 2, 3 for these 3 intervals. And every one of the interval, one n is not included, the other n included. This n included, not included, not included, included. Right now, I can use this one by u substitution. And if I want to integrate that one, if I make this one a u, the du is 2x dx. Therefore, I need a 2 inside, and I'll put the 2 outside. And that become 1 over u du, and that's become a natural log of quantity x squared minus 1. Every one of them, the answer is 1/2 natural log of quantity x squared minus 1. This is the same thing, natural log of the quantity x squared minus 1. But this end is from b to 4. This one is from 0 to b. This one is from a to 0. I'm going to evaluate it, then I'm going to take those limits. Therefore, in here, it becomes 1/2 natural log of 0 minus 1. Minus 1/2 natural log of a squared minus 1. If, remember, I am trying to evaluate from -1 to 4. If one of these 3, the area under the curve become diverge, or it become a large number, I don't care if these two are small. Large plus a small is still a large. If the first one diverges, I don't even evaluate the rest. It's gonna diverge every one of them. What does it mean? Means I have a family, wife, son, and a father. Is father a billionaire? I bet you make everybody a billionaire. But if the father is not a billionaire and it converges, I have to evaluate the son. But if the son diverges, I'm not going to do the wife. But if the father converges, the son converges, I have to do the wife. If all 3 converge, the whole thing converge. If one of these 3 diverge, the whole thing diverge. Only one. But if the first one diverge, ignore the last 2. If the middle one diverge, the last one you don't have to do it. Otherwise, you have to do the last one. Therefore, when I put 0 here, what is the natural log of a -1? It's undefined. And when I take the limit as a approaches a -1, and when I put -1 here is a squared, 1 minus 1 is 0. 0, natural log of 0 is also undefined. Therefore, I'm not going to evaluate the rest of it, and I'm going to say this one will diverge. And somebody said, I don't trust you. I said, that's fine. Don't trust me. You trust the calculator because you probably wrote the program. I put x divided by, not times, divided by, open parenthesis, x squared minus 1. Remember, I was from -1 to 4. I'm going to put a -3 right here. At least I can see a little bit to the left. And instead of a 4, I'm going to put 6 in here. And I'm going to graph. Do you see that asymptote? Do you see that asymptote? Okay. The question is here, I'm going to go and I'm going to find the area under the curve from -1, remember that, -1 to 0. -1 to 0 is here. You know I cannot integrate -1. I go to math and I go to number 9 and I said integrate it from not -1, -0.9. That's almost -9 to 0 of y1. Respect to x, let me see if it's what is the area under the curve? 0.83. How do you say this one diverges? Remember, -0.9 is not too close. That's about 1,000,000 miles away from -1 because I can put too many 9s in here. I'm going to go right here and remember, I'm going to put one more 9 in here and look at what happened to 8.3. Just because of one 9. Okay, I'm going to go back right here and I'm going to put right here 2 more 9. Look at what happened. Oops. I go to 2 more 9. Let me see what happened. It was 1.95. Do you see how long it takes for the calculator to compute? Then I promise you, if I go right here and put which calculator doesn't have enough room to evaluate, that number is going to be very huge. Even the calculator doesn't have enough memory maybe to do it. And that number is not going to go to, see, 10. Look at how much I add. Almost nothing. Therefore, you see this one is going to what? Diverges, because it's moving up. It's going from 4. Somebody said, okay, how about that piece? Well, that piece is from 1, but I cannot put 1. I'm going to put 1.111. I'm going to delete the rest of them. And I'm going to put 1, and I'm going to do 4. See? Whoops. And I'm going to press enter. Look at the area under the curve. Only that piece. I'm sorry. Okay, 5. Let me go add one more 0 here. And remember, how many zeros I can put in here? 1 billion of them. I bet you if you put 1 billion of those 0, that number is going to be way more than 5. Therefore, you see, this one going to diverge because the area under the curve is getting larger and larger and larger and larger. And look at that. But how many zeros I can put in here? If I go back right here and tell the calculator, I want that many zeros, and this is really limited number. When I talk about zeros, I'm supposed to put 1 billion of those zeros in there. And I'm going to press enter. Let me see what calculator does. If it become to 8, I'm okay. It's going to converge. If it become pretty much 8, like 7.93. But look at how long does it take for the calculator to find the area under that curve. And see, they said, I'm sorry, that's almost 1. It almost estimated to 1, and it said divided by 0. See, this is almost 1 because they got this one upon what? 1.000000001 and consider as a 1, and they said that's undefined. Therefore, you see this one is going to become a divergence. Okay, let's find something else, and let's put right here 1 over 1 plus x squared. And you know the domain of this one is all real numbers, but I'm going to go 1 to infinity. Therefore, I'm going to put right here, this is an improper integral. Instead of infinity, I'm going to put a, and I'm going to take the limit as a approaches infinity, 1 plus 1 over x squared dx. I hope you know this is a squared plus b squared. A squared plus b squared is the sum of two perfect squares, and that tied to arc tangent of x from 1 through a. Arc tangent of a minus arc tangent of 1. Tangent of what angle from negative power over 2 to power 2, because that's the inverse tangent, is 1 is power 4. But for that side, I have to take the limit as a go to infinity. Oh, what is the tangent right here? The tangent at power over 2 is undefined. Therefore, what is the arc tangent of infinity? What angle is tangent is undefined? Is pi over 2. Therefore, you have a pi over 2, that's a pi over 4. Subtract them. Look at that beautiful problem. That's really converges. Even though you go 1 to infinity, because the area under the curve, that's the reciprocal of what? Reciprocal of what? I shouldn't scratch the 1 right here. That's the parabola shifted up 1 unit, which is right here. I'm talking about that one, not that one. See, parabola shifted up, but when I flip it, reciprocal of 1 is 0, reciprocal of infinity is 0. That's my graph. And see, from 1 to infinity, oh, it does converge to a number. What I mean, it approaches this, but I don't know exactly what it is. Therefore, this one, I'm going to call it converge. Therefore, you have to be very careful that if you do have, for example, from a negative infinity to a plus infinity of 1 over 1 plus x squared dx, remember, the lower limit and upper limit both are undefined. Therefore, from negative infinity to positive infinity, yes, you call this one a, you call this one b, but you cannot have both and undefined. You cannot have two limits. Therefore, you have to go right in the middle of it right here and pick some number like 0 and make that one a bracket. And then you go from a to 0 plus 0 to b. Then you take a limit for that one. You take the limit of that one. This one, a approaches in negative infinity. And this one, you take the limit as b approaches plus infinity. And you write your integral here and you evaluate. That was the end of the improper integral. I hope you enjoyed it. If you have any questions, please shoot me an email and I'll do some more example. Bye.